In example 3, we're going to use the inverse properties of logs now. And the inverse property has two forms. The first form, log base b of b to the m equals m. So the exponent on the argument of the log, when the base of the log matches the base of the argument, the exponent is the answer. And then we have the form b raised to the log base b of m equals m, and that's when your base of the exponential matches the base of the logarithm in the exponent, then the argument of the log is the answer. So we want to look at example A. It's in logarithmic form, so we're going to use this form, the log form of the inverse property, and we need to make the bases match. Now you cannot change the base of the log. So since the base of this log is a 9, our only option to use this property is to make the base of the argument also a 9. And 3 squared is 9. So I can rewrite this log base 9. And then instead of 3 raised to the 2x power, I'm going to evaluate that 3 squared to be a 9 raised to the x power. And now that I've got my bases the same, they're both a base of 9, my exponent is the answer. And so this is equal to x. Okay, in example B, the log base 2 of 16 to the x power. Remember, we can't change the base of the log to use the inverse property, so we have to change the base of the argument of the log to be a base 2. So 16 as a base of 2 would be 2 to the 4th power. So we'll rewrite this as the log base 2 of 2 to the 4th power. And that's to the x, so it would be a 2 to the 4x. Now that the base of the log matches the base of the argument, the exponent is the answer, which is 4x. Okay, then in example C, log base 27 of 3 to the 6x power. Okay, 27 we can't change because that's the base of the log, so we need to change this 3 to the 6x to be a base of 27 in the argument of the log. And 27 is 3 cubed. So I'm going to rewrite this as the log base 27 of 3 cubed, that would be 27, but I need that to equal a 6x up here, and right now it's a 3, so that would be 3 times 2x. 3 times 2x. Okay, so 3 to the 3rd is 27, so that would be written as log base 27 of 27, and then that 27 is to the 2x power. I evaluated the 3 cubed to get 27. And now that my bases match, my answer is the exponent, which is a 2x. Okay, so now we're going to use the other form of the inverse property where the log expression is in the exponent. So we have a base raised to the log of the same base of the argument m. When the bases match, then the answer is the argument of that log in the exponent, which is m. So in example D, 4 raised to the log base 4 of x cubed, the base matches a base of 4, and so the answer is the argument of that log in the exponent, which is x cubed. Okay, then in example E, we have a base of 3 raised to the 2 times log base 3 of x power. So our bases match, but we have a coefficient here on this log that is not present in the inverse property. So we're going to use the power property to change that coefficient into an exponent on the argument of the log. So that's 3 raised to the log base 3 of x squared. And now that our bases match and we're in that inverse property form, 3 raised to the log base 3 of x squared, we take the argument of that log, x squared, and that is our answer. Okay, then in example F, 125 raised to the log base 5 of the quantity 2x, and we can't change the base of the log. So to get these bases to match, we're going to have to rewrite 125 as a base of 5. And 125 is 5 raised to the third power. And then we still have our log base 5 of the quantity 2x in the exponent. So 5 raised to the 3 log base 5 of 2x. And then we can use our power property, right, to make that coefficient on the log expression into an exponent. And we'll have matching bases now. So 5 raised to the log base 5 of the quantity 2x cubed using the power property. So now that our bases match, we have bases of 5 for both the exponential and the log. Now we can take the argument of the log and make that our answer. And 2x quantity cubed, the 2 gets cubed, which is an 8, and then the x gets cubed. And our answer is going to be 8x to the third power. And that brings us to the secret question for this lesson. Has 3 problems, A, B, and C. A is using the 1-to-1 property from example 2, and then B and C are using the inverse properties that we just looked at in example 3. So go ahead and work these out on your own paper. You're going to upload the work as the last page to your notes in Schoology, and then you'll enter your answers to those 3 problems in the Dropbox or the question for the secret question in Schoology.